for the next 30 minutes, where I want to share some insights, some considerations, and some recommendations if you want to build a specification on top of MQTT, or at least create a comprehensive documentation of how you are using MQTT. My name is Jens Deters. I'm Head of Professional Services at HiveMQ, and especially the Professional Services team frequently faces the customer situation where we have to discuss on how they want to really use MQTT, the topic structure, the payload, some nice to use MQTT features that are built in, or how to improve on usage of MQTT because of the features that are not built in. So as you might know, basically MQTT is so diverse and so versatile that you can do so many things with it. It's so flexible, but this also leads up into the situation that devices and endpoints have different topic structures or different payload schemas, different MQTT version. MQTT has no built-in workflow definitions. It's no built-in device and state management. And very important, the vanilla MQTT only supports basic authentication with like your username and password. And due to the fact that MQTT is TCP IP based, it's always recommended to enable TLS to have at least transport layer security. But that's basically what's built in the standard of MQTT. So you definitely need a broker that supports more sophisticated security features and authorization mechanisms. There are already a lot of specifications out there, and the number is growing. So these are a few examples. The Verbund Deutscher Verkehrsbetriebe, the VDV, they have created a specification that is MQTT-based. They call Internet of Mobility. There's a specification for railway communication, especially for international railway data exchange. It's called Sphera. Currently, we are working together with the Stadtwerke München. We are working on a specification that takes care of smart grids and exchanging information with energy management systems in buildings. Yeah, and of course, there's the spark-plug specification that recently became industry standard. But if you don't want to go or could go for these kind of existing specification, you should create your own custom specification, or as I said, at least a detailed documentation of how you are using MQTT in your use cases to really make sure that your usage of MQTT fully meets the specific needs of your projects and your use cases and applications, and to make sure that you really benefit from the flexibility and the versatility and the features of MQTT. And maybe also specific broker requirements and broker features. So how to start? First of all, you should make sure that you're pretty good educated on MQTT. One way to do that is to join our recently launched HiveMQ University. We have already published courses that enables you to earn the certification as a certified MQTT associate and an MQTT 311 professional. We have course stuff, video materials, anything you need to prepare for this exam, and go ahead and earn your LinkedIn badge to show your MQTT skills there. And especially in the customer situation, when we're talking to customers and they want to go for MQTT, we frequently get aware that they have slightly in some cases, no idea of MQTT. They're just thinking of usage of MQTT to be a data transport layer, and that's it. And they don't have an idea of how certain topic structure, certain payload formats, and other features and principles, they may take advantage of that. And this also has a crucial influence of how the actual architecture look like. So you should start by defining your primary use cases. Really sit down and start a document, not only on audio, but really write down what you would like to achieve, the root initial definition of your primary use case. And this is crucial because the specification will develop differently based on your use case and your environment and your domain. Smart building will develop differently than communication fleet of ships, connected car environments, or manufacturing use cases. Also, the next step to consider is which MQTT version is available in your environment. Most of the devices out there that I've seen, they only support MQTT 3.1.1 by now, but you should really go for MQTT 5 because it adds a lot of features that are really interesting and usable and key for MQTT communication. The disadvantage of MQTT 5 is that some of the provided features are optional, so you cannot make sure that they are supported either by the client or by the broker. So that's why it's so important to have a documentation on that, which features are required to make sure that your building blocks are really supporting that. So some typical examples and considerations. If the status of the client is needed to be tracked, you will need the former so-called last will and testament. Now, these days, it's just called will, and the retain flag to make sure that the last known good value and the messages are stored on the broker and being available. If you need fail safety on client side, you should use shared subscriptions for the backend applications. This is a built-in feature of MQTT 5. If different payload formats are used and have to be validated, MQTT 5 provides these features of user properties to add additional information in the header of an MQTT message or packet. And you can also make use of the payload format indicator and a payload format and a content type description. And also a very interesting feature of MQTT 5 in some cases is this request response pattern that is built in. If you need really an end-to-end delivery guarantee and you need feedback of the receiver of your message. So defining a topic namespace and a topic structure, this is probably the toughest stage of a MQTT specification. In general, it's a good pattern to follow that topics should contain information for routing and filtering, and the payload really only carries the data. And if the topic already contains some semantics, this is really key to be able to filter effectively for the data you're really looking for. You can also make use of existing specifications as a guideline. So if you're not happy with the current feature set of Sparkplug, you for sure you can use the specification itself and modify it to your needs. So if you really need and insist on quality of service 0, quality of service 1, you can make use of quality of service 1. It's not forbidden. even if you're in a Sparkplug environment. But this should be very well documented because this is an exception of the specification itself, Sparkplug in this case. So, starting your topic structure by define your namespace to define the domain and add already a kind of semantic to the topic structure and your namespace. And next key thing that is really recommended is to enable versioning. So a bit like it's a common pattern for REST APIs. This really makes sure that you're future-proof if your topic structure evolves and you have different requirements to your topic structure. So enable versioning really makes sure that your specification or your topic structure is future-proof. The Sparkplug has a combination of these, so Sparkplug B version 1, but you also can add an extra segment to your topic structure here. And really important is to add a variable client ID identifier or some kind of identifier of your client. It can be the client ID, or in a connected car use case, it could be the vehicle identification number. But this is really crucial for many different things. First of all, it's important to enable a role-based device access and to enable not only authorization, but not only authentication but authorization, in order to define if a client is able to subscribe to a topic, is able to publish to a topic at certain conditions. But this is also key to be able to address a certain device. I've recently seen an architecture where they used, they wanted to connect to 200K devices, but due to the limitations of their cloud provider they are using, they were only allowed to use one topic, and they had a combination of 20 different broker instances. And in order to address a device, like to initiate a firmware update or send a command, they had a 12-step lookup procedure to find out to which broker a certain device is connected, to send that message to that broker to that one topic, and then all of the connected devices are receiving this message and have a look at the message if it's dedicated for them. So think about that. And if you're using this kind of approach, you're able to directly access and address a device. So you can get rid of all that kind of overhead with just following this pattern. Some examples of using the client ID for authorization. So in the you are defining a topic pattern, like the first one here with the plus wildcard. So this means that client is allowed to access all topics that follow these pattern, like MySpec version 1 client ID ABC or data with quality of service 1, and is able to publish and also allowed to publish retained messages. And the next topic pattern defines that the client is allowed to subscribe to any topic with QoS 1 and 2, and also to use shared subscriptions here. I think in order to save some time, I will skip these example slides, but they will be included in the slide deck you can download or get after these sessions. So defining the payload format. Some considerations. First of all, is there one payload format that can be used for your use case, or are there different format and schemas and types of payload needed? Is low bandwidth required? Then you should go for a binary format like protobuf or avro that can be structured here and also be compressed. And if readability is required, you should go for formats, like plain text formats like XML, JSON, or also YAML. And it's always also a good pattern to provide this schema to clients within your topic structure to be present to check the data format and the schema. So it could look like this one. Assuming client group 1 needs this readable schema, you can just store that schema on the broker as a retained message in order to check what the current desired schema here. With JSON and for the client group 2, there's an XML schema definition that is stored again as a retained message. If you can afford to go for MQTT 5, it may also be interesting to make use of the content type. So in this first example, the content type is application JSON, so it's defined like a MIME type. And the other example is that the payload is binary, and the content type is just the data type of the content that you are receiving in the payload. And it also makes use of user properties. So you're able to, in the first example, the timestamp and the metric name is part of the payload. And in the second example here, the timestamp and the metric names is part of the user property. So you can subscribe for this topic in order just to receive the actual value. And you have a more detailed description in the user properties here. So next is in flow and state management. So it's also crucial to think about which kind of quality of service level you need in a certain for certain use cases. So if you are dealing with high frequent data like telemetry data, frequent update from sensors, monitoring machinery, you should consider to go for quality of service 0 if you can afford that one or two or certain data points are missing because of the high frequency of the updates. If you have to deal with status information or make sure that the sensor data is really delivered, then you go for quality of service 1, of course. And in some cases, quality of service 2 is necessary for business critical data to really avoid duplicates to be received by the clients or to be sent by sensors. And again, also request response pattern of MQTT 5 is very handy if you want to get a state response from between sender and receiver. And very important pattern is report by exception. Report by exception basically means only the changed data is transmitted. This really saves a huge amount of bandwidth and messages that are sent. You can, if you're following the poll response or request response mechanism, or also your edge devices are sending all the data, even if sensor values have not changed once a time every second, then you really might be overloaded of all the available data, and it's not necessary to transmit the state of a door that is still closed, that it's still closed every second. It's only interesting to receive the change of a state or a change of a value, and this is meant by report by exception, to only push the necessary changed data that is interesting. Next, security requirements. As I said, basically MQTT only supports username and password, but in a real enterprise and serious implementation, you need much more than like JWT tokens or OAuth2 authentication and authorization. You might need to connect your existing Active Directory to your authentication system. As this could not be basically done with vanilla plain MQTT, you need to go for a solution that supports all that. So, for instance, HiveMQ has a comprehensive framework around that to support all these kinds of authentication and authorization. And last step is to set boundaries of your specification. This creates, to really describe what this specification or your documentation of the usage of MQTT is meant for, and where are the boundaries of this. So especially if you want to create interoperability with other systems and other participants in your network and in your architecture. Also to create clarity and consistency on what you want to achieve with your MQTT use case and where the other boundaries are. Okay. We have compiled a white paper that is available on the HiveMQ website that contains all these information that I just introduced, and also a much more detailed information on what you should consider if you want to go for MQTT for your use cases and your applications. Okay, thank you for your attention.
Mm-hmm. So I think we're going to check a few questions, and then after that we break for tea, 15 minutes, and then resume with John after that.
Hey, thank you so much for the presentation. It was really useful. I have a bunch of questions, but I'm going to stick to maybe one and then two if you have time. So in our experience, we started with report by exception. Mm-hmm. Once we added stream processing, we noticed that it was really hard to detect failure and delay when you have a report by exception architecture. So we decided to take the trade-off of actually publishing all the time to make the stream processing part not have to fill forward and detect failures or delays. So how do you deal when you have report by exception? How do you deal with this trade-off effectively?
Question is if you really can deal with this. So maybe your approach to, in this case, send all the data and have a stream analytics later on, that's the way to go. Because if you only go for report by exception, there might be there might be some data points missing in between that are relevant here.
Yeah, and we can't detect if they're missing or if something failed. So that was the problem.
Yeah, exactly. Because if you have a report by exception, you may not get an update for hours because the value hasn't changed. So you're not aware if the service is still available or not, right?
Yeah. And on that note as well, we also had, in terms of format, we started with Sparkplug because of binary is more compressed, etc. But we're actually shifting to using a readable format inside both the edge and the cloud. But then to reduce the trade-off, we actually use a binary format just for transmission between the edge and the cloud. So you actually can get the best of both worlds by using readable on the system, and then just for transmission, you change to compression. And we would really love if any broker supported this natively instead of us having to do applications on top.
Yeah, I think we have a solution for that.
Yeah? We'll talk later then.
Yeah.
Cool. Thanks, guys.